Good evening, good morning, good afternoon, everyone. We hope you're doing well and are staying safe. On behalf of AIOUG, this is Aishwarya, and I would like to welcome you today to the next session, rather, a final session in the series of webinars on maximum availability architecture. At AIOUG, we aim to provide a platform for like-minded technical professionals to grow, network, interact, and share. We, in our aim to keep you excuse me, in our aim to keep in step with the latest trends and enhancements in the database world, we try and bring the best of the technology to you in whatever manner we can. We usually convene every month across multiple locations in India for our monthly meetups, but nowadays, due to the pandemic, we have switched to the online mode, that is a webinar series. And just to keep it more specific, this month we've been focusing on maximum availability architecture. I'm sure you've been a part of most of our webinars this month on the topic of MAA, and today we are on the final webinar of this series, but I would like to extend a very big thank you to all the speakers who have taken out time and have been here, graced us with their presence, and especially Anil, who's been orchestrating this entire thing, and Sebastian, who's on a holiday and still has been extremely kind to us and is here to carve out time from his holiday to share knowledge with us, to share information with us, his experiences with us. So I'm sure you all are going to discover many new things, and I hope you have more questions around it. You are inquisitive, and anything you want to ask, this would be a perfect forum to do so. I mean, reach out, raise your questions, and discuss this. Moving on, a few housekeeping rules. Please use the Q&A panel at the bottom of your screen for all your questions. And in case you need any support from us, please use the chat box. Again, if you feel that you digest something and you've got a question later, or you're thinking about something later, you can always head over to Twitter and reach out to our speakers, who will, I'm sure, who will engage with you and help you the best they can. About the presentation material as well as the recording, both would be accessible from the AIOUG website, so you can log on. Please give us a few days to upload it, a couple of days after today, and you will find it there. Again, we are always keen to hear from you, so we would really appreciate any form of feedback. I mean, you can use Telegram, you can send us an email, but what kind of sessions you're interested in? Is there anything that you heard you want to dive deeper into? We're always all ears for you, for your feedback, so that would be appreciated. Now, moving on to today, I would like to extend a very warm welcome to Anil Nair and Sebastian Solback. Anil, as we know, has been a great supporter of our community. He's been always present whenever we need him, so we're grateful to him. Anil is a product manager of Oracle Real Application Clusters. As we call him, he is Mr. Rack himself. He's been involved with Rack since its inception. I mean, he has helped various customers with solutions and everything Rack, be it its architecture, the performance, the availability, anything about Rack, Anil is the go-to person. And Sebastian is the consulting member of technical staff with the MAA product management team. So Sebastian is responsible for database high availability, disaster recovery architecture, and he's worked with Oracle Cloud Infrastructure Database Service team to support the development of database service offerings with his database expertise. With that, I would like to extend, again, being repetitive, but I'm really happy to have both of you over here. So again, a very warm welcome, and could you kindly take over the screen sharing?
Sure. There you go.
Yep.
I hope everybody can see this screen. Thank you once again for having us. We really appreciate it. I'm Anil Nair. I'm the product manager for Rack. Between Sebastian and myself, I would say, even as a, without giving up too much Sebastian's age, 40 years of combined experience just between us. And it's not just the two of us. Remember, we have a whole team who have just been doing this like for the last 20 years. And this presentation is about the lessons learned, what you should have done, what you could have done, and so to make sure that both your database is available, scalable, and it, not only your databases. Remember, database up when the application's down doesn't help. So combined 360 degrees so that everything is running on your, most, people say, hey, this is my platform Linux, that, my platform is something else. Well, regardless of where you want to deploy, we have collected some of the experiences, tried to condense it into a slide deck. Hopefully, this is more of information sharing, and then you can always please feel free to come back to us saying, hey, can you share a little bit more about a certain deck or certain technology we talked about. Again, my Twitter handle is RackmasterPM. Please feel free to send me a message or just tweet about a question or whatever if you have. And there are some links I provided there. I talked about various different technologies in Sangam and other forums. So my decks are there. So if you ever want to go through what is Anil talking about when he said blah, you can always find it there. And if not, you can always say, Anil, we want to know more about a topic, hopefully very related to Rack, and I'll be happy to come and do another session for you guys. Sebastian, you want to just introduce yourself, please?
Yes, so you probably can't see me because the screen only allows one presenter to share, but that's okay. So you just will see Anil. So I joined the team of the MIA team a short while ago, but as Anil pointed out, I'm working for the high availability disaster recovery from the Oracle database for the last 20 years. And I had a brief excursion, so to speak, into the Oracle Cloud Infrastructure world, where I did help building up the cloud service and cloud services, which we essentially have there. And the idea for this presentation essentially was that we essentially take whatever we have learned during the deployment of high availability databases in the Oracle Cloud as essentially things which are not just there, this is only working in cloud, this is also working on premise. And so we just wanted to take back whatever we learned in trying to run a high availability disaster recovery platform for our customers. That what can you take back of that into your on-premise world? And even if you do choose different platforms to run your database and database services, what is the foundation and things where you really can make use of? And that was the idea for the presentation. And so we said, okay, let's cover these things which you definitely, hopefully know from on-premise, from Anil and their side. And let's add a little bit of experiences from the Oracle Cloud, which I have brought over to the MIA team in the last few months.
Great. Thank you so much, Sebastian. So having said that, let's move on. So this deck is divided into 5 high-level reasons about, what are the typical aspects that we have to consider. I'm the product manager for Rack, so Rack is my baby. Therefore, the first slide is Rack. No, it's just about when you deploy databases, you only talk about one application, one database. That used to be the thing about, I would say 10 years ago. And then eventually we are getting more and more into this converged database where you have a lot of PDBs, or even if you have 1 or 2 databases running on a 3-node cluster, 4-node cluster, where you even could say, hey, my first node will run database 1, second node will run 2 and 3, or whatever, however you want it. That is one of the things that is very unique about Rack, is it gives you customization capabilities. What I mean by that is you could have a certain OLTP load running on one node and certain analytics workload running on some other nodes, and you could change this over time depending on how your business is running. We not only does Rack provide you HA for databases, which we talked about all the time, it provides you what we call as HA against all component failures. And this is very important, right? You could have a private network issue. We do provide you ways by which you can have redundancy for your private network. And what happens if all the redundancy fails? Well, we still have a solution. We even have public network failure, which we detect and make sure that your applications can move. Storage issues, obviously, regardless of what it is, whether it's the entire storage down or whether it's a typical disk down, or there is some kind of RAID issues. If you use the Oracle features, including like ASM, I call it as a part and key feature of ASM, is to provide redundancy for Oracle Real Application Cluster deployments, right? And what about compute? There's a memory issue or memory crash or OS crash. Something happens, the OS is down, OS is hung. We take care of all of them without the customer having to configure or do anything manually. It just happens automatically, right? That is the part where we have the unplanned downtime. Now, what about the planned downtimes? Now, recently, as you know, you would have to apply patches for your operating system, patches for your database and GI. Now, you could typically do this application of RUs and operating system patches, using what we call as this planned downtime. Planned downtime is the ability to move work away from a node, and then you apply your whatever fixes you need, you get it up again, and then move the workload back. Again, the moving workload back is optional, but you could do it. Okay. There are advantages over things like live migration and VMHA, which basically both of these guys, do not provide or do not understand database sessions. So when we say we have a drain out, we implement it such that if you have hundreds of sessions, we drain them out over a period of time. Because if you just move them all, the other node may get overwhelmed because suddenly you're getting hundreds and hundreds of sessions. And it's not just about the session, a number of session count, it's also the work they're doing. If there are only 2 sessions, but they are very busy, then it's extremely hard when you suddenly move them over. So we have drain timeout that you can specify as the upper bound. Now, one thing very unique about the drain timeout is you could set up a drain timeout for 30 minutes. But if we are able to move the work within that 25 minutes, then we don't wait for that extra 5 minutes. So it's kind of like a very unique and elastically changing. That way, you are not waiting on some high level value. About live migration, well, as I say, there is typically once a month I get some question about, hey, Anil, we initiated this live migration and it's not done yet. Well, that happens on systems which are very busy, because remember, live migration requires that the memory be completely synchronized over to the other node. And if you have a database which is very active, and trust me, most rack databases that I work with are very, very active. So by the time the memory is synced up, the changes piled up that the VM migration, live migration doesn't or cannot kick in. So this is a much easier solution because we are moving the work of these sessions to the other nodes, and then moving the databases or the services to the other nodes, so that we have a planned way to move work to the other side. And therefore, customers or end users don't even sometimes realize that, oh, my node is done, because we automatically move them over. Okay. Sebastian?
Yes. So when it comes to, you already told, okay, real application cluster is really the basis for a lot of Oracle applications to run them in high availability mode. And so therefore, it would really be good to not just have the real application cluster on premise, and also to use it somewhere else on VM platform or whatever you're choosing. And one of the questions we are always faced is, if Rack is so great, why can't I deploy real application cluster on IaaS? So first of all, and you definitely know this from on-premise already, the installation of Rack, while it's really straightforward, the biggest issue is in setting up all the underlying infrastructure as it should be. And do not be mistaken, if you're running on a VM world, it's only getting more complicated. We have to take care of a lot of things, and in the cloud, it's even getting more complicated. And so the biggest challenges we actually faced in the Oracle Cloud itself was, how do you provide shared storage in a real way to have shared storage, and not necessarily just use NFS, but essentially ensuring that this is working correctly? How do you deal with IP address failover if you're having virtualized networks and things like that? So there are a lot of things to consider. And while you definitely could come up with a long list of things to do, to check, and essentially make it possible to install a real application cluster, there are still a few knobs which needs to be turned. And as this is really, really very complex, and Oracle said, oh, well, we already have a lot of customers on premise who have difficulty setting it up. There was the simple strategic decision to say, look, we do want that customers are running real application clusters, but we also want to ensure that the setup is always the same, so that you don't face an issue which other customers don't face, and the other way around, that all the issues we already know of are solved. And so we decided that we will not even for the Oracle Cloud Infrastructure itself, will allow customers to install real application cluster themselves, because it's simply too error prone, and you could have a small handle which is wrong. And so the decision was made, no, you only get it as a predefined server, either as the real application cluster on VM, on VM, or as the real application cluster on the best platform to run an Oracle database, which is AccessES. And you even can't deploy Rack on VMware cloud service, which you do find in IaaS. And though, just to ensure that if you need ASM and the capabilities of the base foundation while you want to use at least ASM, then yes, standalone service is supported on IaaS. It's just the clusterware part where we have the interconnect and the shared storage requirements, where we essentially say, no, this is not possible. So what are the deployment types which you essentially have, and why did we choose it on? And that should be on the next slide. So you will be seeing that the one solution is the solution with a VM2 Node Rack on IaaS themselves, where we decided to only take block storage, that you have a high redundancy storage. And that is also quite interesting for your on-premise deployment, so to speak, because we decided clearly that because the block storage is already triple mirrored, that there is no advantage in providing an additional layer of ASM redundancy. So we are working with external redundancy in general, which unfortunately, to be honest, now bites us a little bit, because we have these nice features in ASM, which has flex disk groups with the ASM mirror split. But on the other side, on VM level, you can do other things to clone databases, which we will see later. And the only thing which we also recognize is that we do ensure that wherever you run your real application cluster, that whatever is going on the infrastructure level, that this does not affect your real application cluster per se. So we ensure that even if for whatever reason scaling does require a downtime, because if you have memory scaling, especially when you go memory smaller, because you don't need that so many CPUs, we do make sure this is all done in rolling mode, so that yes, it's not really online, but at least that it's done rolling, that when we have anything ongoing with infrastructure maintenance, that we do ensure that you are never running on the same hypervisor, because that would be a real bad deployment if you're having a VM2 node deployment and you would be running in the same hypervisor. And what we do about that one, you will see in a little bit later slide, where I do explain a little bit what Oracle does with fault domains, where you can see, okay, this is how we do ensure that you don't run on the same slot. So next slide, please, Anil. So as you can see, that Oracle does provide the high availability mainly within the availability domain. So we do not allow cross regions, so we don't set up stretched clusters, which technically would be possible. We do still face a few issues in providing that, and there has been a decision which essentially said, oh no, we are going into more regions where we have single AD regions. And that is also where we say, okay, between ADs, we have data guard for providing disaster recovery, but within the region and within the AD itself, we do ensure that a real application cluster runs on different hosts. And there is an internal concept in the Oracle Cloud, which is called fault domain, which you essentially can also take over if you would be building up your on-premise data center that way. A fault domain essentially ensures that is an assignment of hypervisor which are running on the same racks, so to speak, with the same power supply. And the only thing we do on deployment time is essentially ensuring that whatever node runs in fault domain 1 does not have a second node running in fault domain 1 as well. So we always make sure that one host runs in fault domain 1 and the other host, which is creating your real application cluster, comes from another fault domain, so either FD2 or FD3, which you even can define nowadays. And when we started with OCI, you couldn't define them. So this was chosen for you under the cover just to ensure that whenever a power supply goes down in the data center, it will only affect one node. And you can set up the same things when you do the same setup on VMs, for example, just ensuring that your hypervisors are definitely different. And that is also what we do take care of. And this is also what can provide you with the rolling upgrade capabilities. Next slide, please. So the other ways to essentially deploy real application cluster. We started with the 2-node VM, which has a small restriction because it only allows a single container database and not multiple. But that has also to do with the capabilities of these VMs, which we generally have, where you recognize that even with the largest VMs, there's one common critical thing, which is the I/O to your storage, because especially in the cloud world, the I/O storage is mainly dependent on the network which you essentially have. So it's not so much in SAN storage which you have. All is essentially something like a network attached storage, either via iSCSI or other means in the cloud. So you end up on always hitting the network boundaries, so to speak. And we did recognize that when you try to consolidate a lot of databases, especially CDBs, I mean, you all know you are running databases. And so the critical point for databases is the I/O. And so we decided, okay, anything which goes beyond 2 nodes on the VM cluster side will probably also need a faster I/O. And that's the reason why when you go a little bit bigger, it's also quite affordable to essentially run an XSCS, which comes with their own storage. And if you calculate the storage in, you will recognize that an XSCS is not so much more expensive running that in the cloud for an easy way to deploy your databases, which will allow you to run multiple databases. And on XSCS, which you will see in the next slide, we did ensure that whatever happened to the timing for patching, so whenever you have a planned patch, that we do divide the responsibilities. Anil, if you would be so nice to go on one slide, please. Then you see, okay, you ask on XSCS, Oracle does take a little bit more of the responsibilities. So we now do take fully care of the infrastructure, which is the storage cells, the network RDMA infrastructure, plus the hypervisors, but everything else, operating system, grid infrastructure, that is up to the customer and customer responsibility. Even though this is up to the customer to decide when to patch the stack, what is important, and that you will see on the next slide, if Anil is so nice to proceed, that we do ensure that wherever you are patching, we ensure that you can set things like drain timeout, which Anil talked about. Some things are just generically there, but they can be increased to the maximum, so to speak, to ensure that your applications have enough time to fall over from one node to the other node. And this is briefly explained what is happening in general in the basis if you're, for example, doing a VM guest update, so going from one operating system version to another one, that your services per standard have 5 minutes to essentially fall over to the other node before continuing. But you can, as you see with the MyOracle support node, you can increase the timing to up to 1 hour. If your application says, oh, it's nice that we do all this rolling patching and things like that, but my application can't deal with rolling patching so good, I need a very long drain timeout, then yes, this is provided, well, at least up to 1 hour, which at the moment is the maximum. So with that being said, the important point on setting blame timers is definitely services. So Anil, up to you for talking a little bit about services.
Sorry, I thought I was not on mute. Thanks again, Sebastian. So a couple of things, guys. I think there is a lot of information in the last 3 slides. I don't know if there was, to summarize, I would just say at a high level that regardless of cloud deployments or on-premise deployments, there needs to be a good ratio of the CPU to memory to the IO that you can get. So this is something really that you have to plan out. The second part that I would, again, Sebastian can correct me, but I'm just putting this as summary points, so it is much clearer, is you want to make sure that your nodes of rack, when you have different nodes, there are the power supply redundancies and all that is taken care of into account. There has been cases where the switch and the one node was on the same power and the second node was separate. Well, doesn't help, because if the switch and first node is down, the second node cannot come up much, because the interconnect and the other capabilities are gone. So you got to think about it and take care of it. The third thing is the patching side of it, right? Because whatever system you build, you need to patch. And this is some of the things we have done in the cloud, which you can actually benefit from in your on-premise deployment, where it's saying, all right, I need to use, say, example, drain timeout and things like that. There is one thing here, which is this RHP helper. I don't know if many people know what it is. So remember that when you have VM images, the cloud folks don't have access to them, the VMs themselves. They will patch stuff through their own infrastructure. So there needs to be a mechanism when you say VM, restart a VM from outside the VM, pretty much the VM is just going down. We need to have a mechanism in place to let the VM know that, hey, you're going to go down, and therefore move the sessions out. This is what is done by RHP helper. So when you do shutdown of the VM, RHP helper will come in and make sure that the sessions have time to move away. So all these things are part and parcel of the patching strategy. So hopefully those are some of the good takeaways. I'm hoping Sebastian will add if I missed anything. But with that, let's go into services. Oracle RAC has been providing you this concept of a service for a very long time. As I call it, if somebody asks me what is a service, is basically, there are many ways to look at service. I would say services easily allows you to manage groups of session. And these groups of session could be defined by the customer. You could say, hey, this is my OLTP sessions that are coming in. So you could have sales underscore OLTP as a service, or you could move them out into sales underscore OLTP of my most important product. Whatever you guys call it, you can have a group of sessions connect using that service. The advantage is you can manage those hundreds or tens or whatever number of services, the sessions using that service as a group. So you can move them together and you can decide where the services end up. Services themselves can be what I call as a singleton or uniform. This was the typical ones, and thanks to your feedback in one of the open world sessions, somebody came and talked to me about this duplex service. We now have it in 21C, where essentially a duplex service is, you can give, it's an extension of the singleton service, where we would have it running at least on 2 nodes of a cluster. That way, you are able to choose between singleton, duplex, or uniform. And services can have different characteristics for load balancing. Now, if you look at the typical competitor offerings for any database service, a load balancing is done by different, I would say, older mechanisms, like just let's go round robin and things like that, right? In the context of RAC, we have a much sophisticated load balancing algorithms, right? We can let the database instances let the connection pool know that, hey, there is load on my system, so can you resend the connection somewhere else? So we have this things called as runtime load balancing, where you can define either for throughput or service time, or you could do for connection load balancing, and you have a choice of short or long. And we also give you some defaults based on our understanding of the, like I said, the last 40 years, we 20 years each, we know, oh, most of my customers are using this, and so let's go with the default. But there is a choice for you to change it. Okay. Now, it's not a static entity, so things change. Connections could overwhelm a system, workload could overwhelm systems. So we have this feature via what we call as FAN, or fast application notification. We are able to update not only the connection pool, but the sessions themselves. If you're not using connection pool, about the metadata and state. For example, if a certain node is going to crash or has crashed, we would actually be able to send that information, so that the connection pool will now say, all right, I'm not going to send any sessions to this guy because he's told me that it's unavailable, or if it's a public network failure or whatever it is. These are the automation to take care of when an issue occurs. We can also use something like drain timeout, as I said, for services to move them over in a phased fashion. Let's say you have 5 services, you can move them over so that we don't have to do it haphazardly and cause more problems. We also have this attribute called failover restore. So if you're going to use application continuity, you can make sure that certain attributes of the service, and these are all managed using commands that we'll talk about, but you can set those up, those attributes, and benefit from the feature. Sebastian, you want to talk about application services?
So the question essentially comes, now that we have the cloud or something, do I really still need to care about the services? And one of the things which Arne pointed out, the drain timeout is important in general. So please do not forget what you have learned over the last 20 years on premise, that you always should be working with services. The cloud doesn't change anything there. Services are there. Unfortunately, services are not always there when you expect them to be. Like in the case of the real application cluster on VM, we do not create services out of the box. There are some reasons why we don't do this yet, which essentially also had to do with that we didn't do PDB management for a very, very long time. So there was really no way in doing real service management. But essentially, it's the same like on premise. Please do create application services. Never use the default service, which you hopefully know, and then make sure that you configure them as you need them. Set the drain timeout accordingly. Make sure to enable application continuity whenever you do. So on AccessCS, we are a little bit step further, but only really a slight step, that as of today, when you create the pluggable database, either via DBaaS CLI or soon via the console, so it's not there yet via the console, we will automatically create one application service for you, but only a single one. Why do we only create a single one? Now, that's an interesting case, because if you are really having a consolidated environment with lots and lots of databases, and we essentially would be doing, at the beginning, we thought, oh, well, let's do the same thing like autonomous, which I will be explaining in a second. Let's having multiple services automatically created, even though customers might not use them. We do recognize if you have 1,000 services running on your Exadata cloud service, and then the disaster strikes and you have to use DataGuard for the failover, that is affecting your failover time, because all the services have to be started. Now, that doesn't say, oh, services are bad, but yeah, well, definitely having 1,000 services when you only need 50, that's probably not the way to go. So as of today, that's the reason on AccessCS, we only create a single service, which you can decide to use, or you can decide, oh, well, I need another one, let's create another one. That is okay. You don't have to use that. In case you don't use it, drop it. So this is not needed internally. But it's always important for your applications to have application services and to look at the capability. In general, just ensure that if you are working with services, think of all the nice things which we have as fast application notification. And what we essentially also did find out, yeah, customers were using services, but they did forget that it might be a good idea for the Java applications to open port 6200, which is the ONS port in the security list, or make sure that it's enabled on the firewall IP tables itself. Also, small differences here on DBCS. As of today, we do use IP tables. On AccessCS, we are not using them. So yeah, just make sure. So if we are looking at the other services which Oracle have, Anil, on the next screen, then you will see that on unlike on DBCS and XCS, where we really require you to create the service yourself and make sure all the settings are yourself, on autonomous, we do create them automatically. So autonomous shared, we do automatically create high, medium, and low, which has to do with the parallelism. We also have, if you are using transaction processing, and TP and a TP urgent, which does use under the cover, it's just standard. I mean, we are using the resource manager within the database to apply the parallelism for high, medium, and low. We do ensure that if you're running an application against TP urgent, that this really has the highest priority. So it's the same thing on premise, essentially just saying, oh, you have 5 services. These are the 5 services. Make sure to distribute the load and make sure to administer them accordingly. Now, on autonomous, you don't have the capabilities to create your own services because that's not available. But at least we need to give you control over how you enable application continuity, which here is specifically with the DBMS Cloud Admin package. And the biggest difference here for autonomous shared is you don't need to care about the fan events, which I just explained before, because they are essentially handled within the connection manager, which there is a connection manager farm in front of autonomous shared, which will be handling all the fan events for you. So there is no requirement for you to explicitly set the fan events. Now, on the other side, if we look on the next slide on autonomous dedicated, which is using pretty much the same services as autonomous shares. Yes, we also have a few services which does not have to use the secure connection like in autonomous shares, because a dedicated autonomous service is owned by you, and so no one else can access it. So there might also not be the requirement that you need to communicate with TLS to the services. You simply can say directly. There it's different, because I mean, there if you have the fan events, it's a stand, even autonomous is using real application cluster under the covers. You have the Oracle notification service, not the Oracle Cloud, but from the real application cluster. A little bit bad naming here. So the ONS from the real application cluster, that is the same functionality. And if you do directly connect to your application service on autonomous, please ensure your network security rules has open port 6200, otherwise you won't get the fan events. Now, enabling application continuity is a little bit different here. There are services which have enabled it per default. As you can see, the OLTP and the services have enabled it per default, but you can also decide on the high, medium, low to enable application continuity if your application does require it. Next slide, Arnie.
Thank you. All right. Thank you, Sebastian. So I have taken a little bit detour from database and talking more about database availability to also talk a little bit about what can you do for providing high availability for your application. So there are 2 high-level topics that we can talk about. One is the application VIPs or virtual IPs for use for applications, and then we have this HANFS. So think about it this way, that what does an application need typically is a database endpoint to talk to, and you can obviously we have scans and all that, but remember that the application itself can use a VIP so that the application can move over between the different instances. So typically when you have some kind of connection that you're or some kind of network that you need, it's typically a physical IP which is set up to a particular host. If that host goes down, the IP is not around, and the end user will get errors to access while accessing the application. What we have provided with this feature is that if you could actually define your own virtual IP, and we will take care of moving the virtual IP between the different nodes. So we are taking care of the IP problem. So how do you do this at a very high level? You would say CRS-CTL add network. You would add the type that you want to set that network to. There is an app VIP CFG. And trust me, if you're going to go to 11.04 versions, you might see some differences. I've just taken the latest high-level commands from the 19C release, and this is what you would do. Once you create the IP, your application now can move between the nodes of rack if you want to. Basically, it's a cluster-aware function, but still, when we want to differentiate it into the context of what we're trying to explain here, is there are two aspects that you need for high availability of application. One is the network, and one is if there are application configuration files, if there are application files that they write to, then even that needs to be highly available. And we'll talk about that in the next one, which is basically what is we call as highly available NFS. So what is highly available NFS? Well, think about it this way. On the left-hand side, you have a rack cluster, you have an ACFS mount point that you want to give to different users to use, and these are different applications. So you could have a portion of ACFS being mounted with /HR for certain set of users, /ERP, /account, and /sales. Now, as a DBA, typically you are not involved in the day-to-day activities of these mount points and all, but this is something that has to be done or could be done to make sure that if, as on the right-hand side, we see that there is a disaster, there's one of the nodes are failing, then we are able to easily move them from one node to the other. So you can see that this ACFS is using the node number 4, and I'm just calling this 4 as the 4th node in this section, and they're all using this mount export options to provide these mount points to different end users. This could be an application, and I just use 2. You could have whatever number you want. Now, when there's a catastrophe, you can see that they are now using 3rd node to provide the same services. So you have both availability for the network, and we also provided availability for your storage, so that when your applications are accessing things, you do not have to go back and change their IP address or remount systems and deal with stale file systems and things like that. Okay. So at a very high level, what do you do for providing HA for your application? You create what we call as the HA VIP. Then you add export FS. These are all the series of commands, and the documentation actually does a very good job going over it. I just provided a high level set of commands. After you do the export FS, you can start the HA VIP, and then you can check the status to see if the mounts are available. Then you can you can configure the HA VIP. You have to do this, some of the commands as root, which I've kind of tried to highlight with this hash, which is the typical thing you would see when you need to run via root. You would mount that on the remote side. You can test it using the relocate HA VIP. This you can do for either planned or just for testing. Planned maintenance allows you, you can do the relocation to pretty much seamlessly move the mounts. And then you can check where it is running as of that moment after you did the relocate using the status export FS. So hopefully you understand that now that when you use the grid infrastructure, which is a component, I would say, as part of Oracle Rack, you would get features where you obviously get the HA and scalability for the Rack database, but you also can make sure that your applications are also highly available. Okay, Sebastian?
So the important part is that what Anil has shown to you, that you can create additional virtual IP addresses and therefore ensuring that your applications are highly available. This is something which also works within OCI, the Oracle Cloud. A few customers which are running SAP applications on Oracle Cloud, on Exadata Cloud Service, where this is definitely required. Now, when I had first, about 5 years ago, talked to SAP about this capabilities, they essentially created the virtual IP address under the cover as you would have done for a normal real application cluster on premise, and said, oh, this is all working fine, but I can't reach the virtual IP address from my second node. So I can only use it from internal. And one of the reasons is if you are working with virtual cloud networking layer, it's not sufficient to just create the application IP address on the server itself. You also need to educate your virtual cloud networking layer that you now have added a secondary IP, which on the networking side of IaaS is called floating IP. And so what is required is essentially to create all the resources which you know before on the Exadata or on the VM cluster with the SRV-CTL command or AppVip-CFD command, depending on what you want to use, like HA-NFS, which would also be supported. But then you also have to educate the networking layer that you created a secondary IP address. And that is pretty easy. There's an OCI network VNIC assigned private IP, which you essentially need to run with the exactly IP address which you created, which we created on the cover. The only, I wouldn't say problem here, is to find out the VNIC ID, where to assign the floating address to, and how to easily get that. I have posted on the second slide, which I included in this presentation, is there's a metadata cloud service, not just for Oracle, but there are also other cloud services which provide this, which will essentially tell you the VNIC ID, which you would be using in the command before to essentially create that floating IP. With that being said, all which you have seen, if you want to have an application supported with the application failover, we generally do support it. Now, in general, we say it's better not to install it on the DBCS directly. It's always better to take a VM. But if you do have like a Golden Gate cloud service, which needs to run locally and which should fail over or Golden Gate in the cloud, so to speak, then yes, you can do this and you can create your VNIC, you can create the floating IP address, and that is fully supported. Now, I just answered a question from a colleague of yours just in the chat about the capability of services with the scaling workflow, which we have in VM, in the VM API. So I have to admit, we should also be supporting that floating IP in the scaling flow. I have not tried this with a scaling flow, but as it would be the same answer. If that is creating an issue, it's definitely a bug. So adding a service is definitely what we want customers to do, and that if that is blocking anything in the scaling flow, that's definitely not as it should be. So we have to correct this. Here, it's definitely working. Now, there's one minor thing that it's still working on AccessCS, but on AccessCS, because we will be providing a new functionality on AccessCS, essentially this adding the IP address will be provided within the console, because there's a slight change, and then you can't simply add it to the network with that simple command. On VM clusters, it will stay working that way, so there's no problem. On AccessCC, you don't need to do this, because AccessCC is running within your customer network. You don't have that virtual cloud networking layer, so the two steps which you have seen there would not be necessary. Anil, over to you.
Thank you. Great. And moving on, reason number 4, we obviously know, and I talked about it earlier, about this concept of converged databases. This is becoming a lot more real right now, because we have this increasing number of data types that we are supporting, like JSON is one data type, the IoT workloads is another one. So it does make sense to securely put all of them together in one database. And when you say securely, you also want to make sure that if that single database instance is down, you want to be using Rack so that you can make it available through the other instances. So for the on-premise customers, folks, I would say that we, at least in the Oracle Cloud, have learned a lot about using different number of PDBs and being able to use Rack to spread out those PDBs across different instances. So in a consolidated environment, you definitely want to take a look at your CPU and memory and other characteristics and make sure that you can easily spread the different PDBs across the different instances. We highly recommend, even though you have different PDBs, you still use a single listener to manage all the resources. This used to be a thing of the past, where you used to have different databases use different listeners. It's a management nightmare for the DBA, because somebody has to remember these things. So much better to put everything in the single listener configuration, so that this can be managed easily. You want to make sure that your services attributes are clearly defined. So in this example, as you can see, you have JSON service running on first node. Well, you want to make sure that you define that if you ever need that it has to be either a singleton or other type of service, then you define it correctly. Obviously, with Rack, we also provide the isolation that is required between the PDBs, both in the cases of our internal the lock manager, we call it dynamic lock manager, and in terms of reconfiguration with our features such as the buddy instance. So we make sure that if your instance does not have a PDB open, then that instance, if it goes down, doesn't affect the PDBs. So this is really something that you can benefit from. Other things you can think about is you can also grow elastically as needed. For example, a lot of the customers now use VMs where they allow dynamic reconfiguration of CPU or memory. Well, if you add CPU or memory, Oracle has had the ability to benefit from that automatically. So we can grow what we call as vertically and horizontally. Like if you have no more memory left, but you still expect a workload, well, add a node, and this can be done without any downtime. This also allows you to protect your investment, because now, in anticipation of a higher workload, you don't have to take away all your servers and buy new ones. You could actually have certain new servers being added as newer nodes. So all of this helps with at least some of the ideas here can be used both in the on-premise world and a little bit more also in the cloud world. So Sebastian?
So when it comes to consolidation best practices, one thing you should know, now that's not a problem for VM Rack, but especially for XSCS and XSCC. We still do see a lot of customers who do say, I only want to open the CDB on a single node, because I'm not doing consolidation on PDB level. You really should be looking at PDB level, and the ideal scenario is essentially then to open the CDB on all the nodes and then make sure your PDBs is only opened on a single node, for example, because you get the failover capabilities, and you also get the advantage of having less memory usage on all the nodes if you do it that way, instead of trying to run databases only on specific nodes, as this also increases the management nightmare, so to speak, if you have a database just open there and open that. And PDBs can essentially be simply opened. And I mean, we do have a lot, what Anil hasn't mentioned, we have done in 19C and I think even in 12.2, we have done a lot of things to ensure that if you open a PDB only on a single node, we also ensure that there is not so much remastering happening, so that whatever happens to access the PDBs, that we do stay on that node if you only know it's opened. And one experience you essentially can simply take, if looking at how Autonomous Dedicated, for example, is doing that automatically for you. If you are launching an Autonomous database, which essentially is a PDB, and you assign less than 16 CPUs, what Autonomous automatically does, it's only opening the PDB on a single node, because it's saying, oh, it's a lot better because you're only using 16 threads, 32 threads, essentially. It's a lot better to have them on a single node, because if you have any parallelism going on, it's a lot better to have them inside a node than trying to spawn with the interconnect. And only if it's going over 16, so up to 32 OCPUs per PDB or per Autonomous database, then it would make sense to open it on two. So with that in mind, you also can essentially on your consolidation already decide a little bit, oh, it might not be necessary if my databases don't need so many CPUs to always have them run in a real application. Well, it's still a real application cluster, but you don't need to open them on all the nodes, saving essentially a little bit of memory here and also ensuring more performance. Because, I mean, let's be honest, the failover capability, if the node goes down where your singleton PDB is running, there's not a lot of difference there. The only difference which you will recognize is, okay, 100% of my sessions will be affected because they were all going to that node. So that's the only difference. But in all other cases, the failover is pretty much same quick as having a true real application cluster when you have the PDB open on two nodes. and you do also get a little bit of performance. The other things which we also often come across on the consolidation is the listener aspect, which Anil talked about. So on the next screen, because there are still customers who essentially say they do have the production and the test databases running on the same host, because they want, I mean, especially for Access CS and Access CC, this comes up quite often, that they say, oh, I do have so many resources, and because I do want to use it for test and for production, I don't want to mingle them. So, and I also want to ensure that whatever network segment I'm coming from, I do not in error access the test instance instead of production and the other way around. Now, one of the things you definitely can do is using virtualization to separate them. But virtualization has some drawbacks, which essentially is now you have to maintain 2 operating systems. You still have to coordinate downtime if the infrastructure is patched. Yes, we have rolling patching, but you do have to patch them separately. And the grid infrastructure, so it's a lot of administration effort to essentially get that. And so is there any other way to do network isolation instead of using VM clustering and instead of using multiple listeners with multiple networks? And as you definitely might know, that XSES, while this might still be possible on XSCC, if you launch different VMs on XSES, we don't provide different VMs yet. We are still working on that one. But we also do not provide the capability to assign additional networks to a single XSES, because we said, oh, you should be using a single listener, so why do you want to have different networks? So there are a few things which you can do already today. And one of the things which is often missed on Exadata, you get Database Vault. And Database Vault provides a very good methodology to essentially say, oh, I'm just restricting the access with the help of database vaults to different network segments. So whenever I'm coming from the production network and it's a test database, we don't allow access. And it's a simple rule in Database Vault. It's not a lot which you need to configure there in Database Vault to just ensure that. You don't need to configure another listener. That's a single rule within the in the database to protect you from accessing from some other network segments, and you're done. Nothing more. So that's the most simple way. However, it will trigger a little bit later because you actually need to be connected to the database that the database vault rule is firing. But normally that's sufficient. If you need more isolation, then another possibility which you have is you could be working with per PDB TLS wallet to essentially ensure that only when you have the correct wallet, you're accessing that. However, that from the administration perspective is quite big. And the last thing, essentially one of my colleagues in Germany has blogged about, is Connection Manager, because that essentially is what Autonomous is using, though they never expose it externally what they really do. But they essentially are using Connection Manager to ensure that accessing to an autonomous shared database is fully secured and segregated and separated. And that can be used the same way. So if you really need the capabilities to separate your network instead of trying to bring this on a single XSCS host or XSCC host, where this will also come in with the problem of management, you could simply say, I'm putting a Connection Manager in front of that and have that one deal with the correct connections and policies and firewall rules, so to speak, to essentially access that. I mean, there are definitely the more sophisticated, which I have not mentioned here, which would be using the Palo Alto firewall things, which are also some customers in the cloud are using to essentially get the same. But that is the easiest thing to achieve this. And so therefore, this will help you essentially in providing segregation without the requirement of spending a lot of resources on different VMs. But as I said, we are doing different VMs. So if that's really the requirement, that is coming on XSCS, but not yet there yet. Anil, I know you are trying to type the answer, but maybe you can go on with the next slide and I will take over.
Thank you. So yes, so the points that Sebastian was mentioning, I have talked about it many times. That's why I did not get into it in a lot more detail. And I call it, this is under the umbrella of what I call as pluggable database service optimization. I have talked about it a lot in the last 2-3 years, blogged about it. But basically, all of these features, and which is also important, is we are continuously improving it with every release, with in fact sometimes every RU. That provides the scalability for the database. You can see a lot of the images I've used here are showing PDBs. So yes, PDBs is the way that you want to plan forward. I realize that that's a big change coming from a non-CDB architecture to CDB architecture. It is though going to make your life very easy, because as I said, all of these features like optimized singleton workload scaling or smart cache fusion and service-oriented buffer cache, all of these will help you manage your PDBs much better. And it's not just manage your PDBs, it's managing the services and the workload and other things to provide isolation and all that. For every release, we are improving it. Again, the details are in the blogs, and if you have questions, feel free to reach out to me. In the interest of time, I will just move on to the summary page, as I call it. This is a very short list of features that we have improved over time. 11.2 to 21C. You can see that we are doing a lot of work, looking at your workloads, looking at customer issues, and saying, okay, what can be improved to make it faster? We also benefit from the hardware changes. So when 11.2 was released to 21C now, the CPU architecture has improved, memory is improved. There are different types of hardware devices that we can use. So we have been able to leverage all that. Sebastian?
So when it comes to scalability, we do have the same for DBCS and XSCS. Essentially, you can scale up vertically and horizontally. Now, one of the differences which we do in DBCS is that scaling alone does not only take care of CPUs, which is one of the reasons scaling on VM DBCS is rolling today and not really online. And that really has to do that we do increase the shape. Therefore, you get more memory, you get more IOPS to the storage, because the network is also dependent on the CPU size in Oracle Cloud. And so the whole scaling exercise here is essentially rolling, which you can also say, oh, when rolling patching is working for my application because I use services, then yeah, scaling rolling is not so bad, and that can even be capable for me to do this on my own on premise and not just in OCI. Now, on XSCS, scaling itself is online. So we do have online scaling, increasing CPUs, but that will not increase memory. So whatever you assign to your database before on the memory side is what you did. If you want to increase memory, and that is one thing which some of you have recognized maybe on XSCC, because on XSCC, where you have different VMs, you can decide to increase the memory. Then this is also rolling. It's not an online scaling operation to increase memory. Now, on autonomous, we have online scaling, and we also have something in auto scaling. Looking internally in how auto scaling is working is really, really interesting. But unfortunately, we don't have enough time to tell you exactly how this is working. But I really want to point out one thing, that auto scaling is not something which is only applicable to autonomous themselves. And on the next slide, you will see that a colleague of mine from Italy and I have released a small Oracle support note, and essentially Roger, my colleague, also blogged about that, is we do allow scaling on XSCS and also XSCC, by the way, in kind of auto-scaling fashion. So you essentially can set up OCI resource principles, and that is only working in XSCS and XSCC. On XSCC, you still have to use username and password to authenticate against the OCI control plane. But then you essentially could be triggering scaling automatically. And I do know that some of my it's a nice functionality, so you do get some kind of auto scaling, but you shouldn't set it too sensible. And we only provide it as a script, so it's not an inbound functionality. It's something you can try out, and you have to essentially see how this is working for you. Reason is it's not an official tool, because an official tool, we would need to safeguard all the MA and ensure that this is working flawlessly. I mean, if we had one case where a customer had the sensibility of auto scaling way too low, so it was scaling up in a few minutes up and down. Now that is not working, because a simple scaling request through the control plane takes a few minutes. So if that happens too often, then what is going to happen is that one of the scaling requests is essentially hanging. And this is one of the reasons the whole capability here, it's not as flexible as autonomous, but you do already have a capability of looking at your workflow and then deciding once in an hour to automatically scale up or scale down. Have a look at that My Oracle support note. I haven't shared the blogs, but if you search for auto scaling and access CSCC, you definitely will find the blog. If you are not capable of finding it, please send me a tweet over Twitter and I will reply with the blogs. So that should also be possible. Yeah, thanks. It took us a little bit longer than expected. I still hope we had a lot of interesting information for you, which you can not just be using in our cloud, but also internally. And as Arnil already pointed out, feel free to contact us if you do have more questions which couldn't be answered today.
Great, thank you, Sebastian. Thank you, everybody, for hanging out with us for the 5 minutes. Sorry it took time. Thanks once again.
Thank you, Anil. Thank you so much for your time. Just 1 second. Let me check if Sai is around.
Yeah, can you hear me okay?
Yes, we
Yes.
can.
Yeah, so again, thank you very much. Huge thanks to Sebastian joining from the vacation. I hope you will enjoy rest of the day, rest of the vacation. And also, we can't end this session without thanking Anil, right, for structuring the entire series and coordinating. And you guys don't understand how much efforts goes behind the scenes, and also the entire Marcus team, starting from Ian, Glenn, Ricardo, Ludovico, Suraj, and again Sebastian, right? So huge thanks. Also, I request all the participants to thank them in the Twitter. As I mentioned, you don't know how much efforts behind the screen. Request to thank in LinkedIn or Twitter. I know something comes free, sorry to say that, right? You attend the session and close it, nobody's going to follow up with you. But I request from by heart, how much efforts, at least just a few lines in the Twitter or LinkedIn. I really appreciate your support. And we also need to thank Aishwarya and Gomati for running this entire series seamlessly. Two women. I think going forward, women leadership is going to dominate. So thank you for that. And also, what is coming next? We are planning to pause webinars for a couple of weeks. I can't share the reason public, but we are working with Oracle on many things because there are some times, I think few months, nothing is happening from whatever we are requesting. So we are pausing this webinar for a couple of weeks, and we are in touch. We are working with Oracle. And the good news is we are going to come back with a huge benefits. For example, you guys going to get a certification vouchers and many things, right? Even Oracle Cloud, all the stuff. So we are not sharing unless we get a proper confirmation from Oracle. So again, it's very huge. It maybe look like you're attending this 60-minute session, but it's not. It's beyond a lot of efforts. So I request please watch this AIoT website. We have really sessions, all the sessions scheduled for October, but we will let you know when we are going to start in September, because Anil also recommended there are sessions from his team on Exadata, XRCS, CCC, all the stuff. So we'll come back soon in a couple of weeks' time, until then we get this demand clarified from Oracle. And with that, any closing comments, Anil? Because it's a last session, but it's not really last session from you. But Anil, you want to say something? Anil?
I think he.
There you go. Sorry, I was going to say it's not over until it's over. So yes, we'll be coming back, hopefully, face to face soon, and be able to meet you guys. Thank you again so much. Thank you, Aishwarya. Thank you, Gomati. Thanks, Sai, for helping us with this. We really appreciate it. Thank you so much.
Thanks from my side as well. Have a good day.
Yeah, thanks, Sebastian.